Welcome back, viewers. Welcome to our fourth video on stoichiometry. If you have not watched the first three videos on stoichiometry, do well to do so, because without those videos you may not understand what we're discussing in this video. Now, in stoichiometry 3, that's the third video, we introduced molality and molarity, and here I want to solve further questions on those two concepts, and we'll see how we can get to the fifth video now. Like I said in video 1, our journey on stoichiometry will be a little bit lengthy because we have a lot of things to discuss. Now let's look at this question. We have not seen this type of question in the previous video. Now the question says, a sample of concentrated HNO3 has a density of 1.41 gram per milliliters and is 70% pure by mass. The question says, calculate the molarity of the solution. For questions like this, there is a normal method of solving questions like this. But in this video, I'm not going to follow the normal method. I'm going to put up formula by way of shortcut, which will give us the answer straightforward. All right. So the formula by way of shortcut, I will introduce that formula here. It says molarity, molarity, capital letter M, equals 10 times percentage composition times density divided by molar mass. Please take note that in this video, this formula is another formula we use when we want to calculate molarity. It's a formula by way of shortcut. I don't have time of proving how this formula come about, but maybe in our next video I may do so. But for now, I said that molarity, capital letter M, is 10 times percentage composition times density in gram per cm cube or in gram per milliliters. And the M naught here stands for what? The molar mass of the substance in the question. Now, to get the molar mass of HNO3, we solve everything here. We have hydrogen is what? 1 plus relative atomic mass of nitrogen is 14 plus 3 times 16. If you do this very well, you are supposed to be getting 63 grams per mole as the molar mass of HNO3. Now, we have gotten the molar mass. What is the density in the question? The density in the question is 1.41 gram per milliliters. And then we are given percentage composition. They said that the percentage composition is what? 70.0%. So what do we need to do now is to put everything in the formula and get our answer. So with ease, we say molarity, capital letter M, equals 10 times, what is the percentage composition? 70 multiply, what's the density? We say the density is 1.41 divide, what is the molar mass? 63. When we punch our calculator, molarity, capital letter M, is supposed to be giving us 15.7 molar. And where do we have that as our answer? Option E is our answer. So this is a formula by way of shortcut we use when we want to solve questions on molarity, when percentage composition is given and density is given. Moving on to the next question, do well to pause the video and copy out the solution to question 1. So this is question 1 and this is the solution for question 1. Like I said, these formulas are equally permitted for theory questions. Even if you are solving theoretical questions, you can still use this formula. This is a formula by way of shortcut, because if I even solve this question with normal method, it will take me time and I will still arrive at the same answer. It then means that the shortcut formula, we got it from the main formula. Moving on beyond this now, let's look at question 2 very quickly. Question 2 says, calculate the molality of a solution. If you look very well, this one is molality, not molarity. This one is Li, not Ri. Alright, so pause the video and copy out solution to question 1 because I want to remove it from there. Then solve question 2 there. Moving on. Alright. Alright, solving question 2, the shortcut formula we use for molality, we said in the second video or third video, we said molality, small letter m, is given by 1000 times m over capital letter M times weight. And I explained all the parameters in this formula in the third video or second video. So here I'll just use this formula to get the answer to question 2 with ease. And I said in that video that this M here is the mass of the solute, while this capital letter M here is the mass of the solvent in gram. And I now said that W is the molecular weight of the what? Solute. So let's quickly look at the question. Calculate the molality of the solution containing 8.89 gram of glycerol. And glycerol, they said, is C3H8O3. Of course, that's the molecular formula of glycerol. So what is the solute there? Glycerol. And the mass is what? So that mass is this mass you are seeing up here. And it is 8.89 gram. If you don't understand what we are doing now, you may need to watch Stoichiometry 1, 2, 3 before you understand this one. Now, 8.89 gram. And then, containing this, this should be in 75.0 gram of ethanol. So ethanol there is the solvent. This question is just like saying glycerol is dissolved in ethanol. Ethanol is the solvent, while glycerol is the solute. So the mass of solute is the mass of glycerol. While the M, which is the capital letter M, will be the mass of ethanol now, which is the solvent, in gram. And what is it there? 75.0 gram. 75.0 gram. Then what else do I need? I need W. And W, we can get it as the molecular weight of the solute, which is the molecular weight of glycerol. Of course, W of glycerol, C3H8O3, can be gotten this way. So carbon is what? 12. And there's 3 there. 3 times 12 plus 8 times 1. 8 times 1 for hydrogen plus 3 times 16. Let's use our calculator and do that very quickly. Alright. So we're having it as 36 plus 8 plus, right, 48. If we sum this, we'll be having 92 grams. So this gives us 92 grams per mole. And remember I said that this is our what? W. In Stoichiometry 3, I said that this 1000 will remain in our formula if the mass of the solvent is given to us in gram. And of course here, the mass of solvent in gram. Therefore, I will retain my 1000 there. So I will now say molarity, that's molality, small letter m equals, then what do we have there? 1000 times, what's the mass of the solute? 8.89 divide, what is capital letter M? 75 times, what is the weight? 92 grams. So if we punch this in our calculator, we're going to get, okay, we'll have it as 1000 times 8.89, then divide by 75 times 92. All right, so this is our final answer. The molality M equals 1.288405. And which option do we have that? 1.288. Of course, that's approximately 1.29. Like I said, you don't approximate until you have gotten to the final answer. Now, this is a shortcut method. If you want to use the normal method to get the molality, we said that molality is number of mole over kilogram of solvent. That's normal method now. It then means we need to get the number of mole of solute first, divided by the mass of the solvent now in kilograms. We are sure going to get the same answer, but I prefer using the shortcut method to get the answer very quickly. Moving on to question 3. Please do well to pause this video and copy out the solution to question 2. So this is an example on molality. When we are done with all these examples, be rest assured that you will not fail any question on all these concepts, molality, etc. This is the next question. Okay, question 3. It then says an aqueous solution is 0.120 molar of glucose. That should be of glucose. All right. And we are seeing that this is capital letter M. Like I said, do well to pause this video because I want to use the space to solve question 3. Question 3 says an aqueous solution is this molar of glucose. And what is that molar there? That should be molarity. And it says, what is the mole fraction of glucose? In other words, we are given mole fraction. A lot of students have been chatting me up, asking me, sir, what if we are given mole fraction and we are asked to calculate molarity? Now, this is the way we go about it. This question is a typical example of the question that the students have been asking me. It says an aqueous solution contains this, and of this, what is the mole fraction of glucose in the solution? In Stoichiometry 3, I introduced mole fraction. Now, you can do well to pause the video and copy out this now. I want to wipe the board. So, solving now, there is a method we use when solving questions on this. When we are given molarity and we are asked to find mole fraction, what do we do? Remember that we said that molarity, capital letter M, is given by number of mole of solute over what? Liters of solution. That is molarity. And are we given the molarity of this solution? Yes. We were told that molarity in the question is 0.120 molar. So this is our molarity now. It then means that interpretation of molarity from the formula, it means that if we are given this molar of a solution, it then means that we have 0.120 moles. That's what it means. Dissolved in what now? In 1 liter, because we say per liters of solution, or 1000 cm cube of what? Solvent. So what this statement means is that we have 0.120 moles of what? Of glucose that is dissolved in 1 liter, from our formula, 1 liter or 1000 cm cube of solvent. And the solvent here is should be water, because water is a universal solvent. All right. And if you remember again, now it then means from here I can get the mass of solute, because we said that number of mole from stoichiometry 1, number of mole is equals to mass over what? molar mass. Can I get the molar mass of glucose? Yes. Glucose is C6H12O6. And I say if you solve everything here, you're supposed to be getting 180 grams per what? Per mole. That is the molar mass of glucose. Do we know the moles of glucose? Yes. What is the moles of glucose? 0.120. Can we get the mass of glucose? Yes. From here, we now say number of mole, 0.120 equals mass over, what's the molar mass of glucose? 180. Cross multiply, we get mass to be 180 multiplied by 0.120. If we do that very well, I grab my calculator now, so you grab yours now. All right. So calculator, we say 180 multiplied by 0.120. We have it as 21.6 grams. So the mass of glucose in that question is what? 21.6 grams of glucose. So this is the mass from molarity. This is how to get mass from molarity. As I've gotten mass of glucose now, why am I trying to get this? Because in Stoichiometry 3, I said mole fraction represented as X. If it is mole fraction of glucose we are looking for, as the question suggested, I said we are going to say mole fraction of glucose becomes mole of glucose over, right? We say mole of glucose over mole of glucose plus mole of water. So that will give us the mole fraction. So this is actually our formula to the problem we want to solve. Then we need to get each of these things. So I've gotten now the mass of glucose. I can get the mole of glucose. And if you get back the mole of glucose, you fall back here. Because if you want to get the mole of glucose now, mole of glucose will be mass of glucose over molar mass of glucose. If you do that well, mole of glucose will be, what's mass of glucose? 21.6 divide, what is the molar mass of glucose? 180. If you do this now, let's see what we have. We have 21.6 divided by 180. We have 0.12. You see that is the mole of glucose. Now, we need to get the mole of water. And we now said that to get the mole of water, let me come over here. Let me move over to this side. To get the mole of water is mass of water over molar mass of water. All right? How then do we get the mass of water? We can get the mass of water from the volume of water given to us. We are given volume of water to be 1000 cm3. And when density is not given, it's usually taken that the density of pure water, because pure water is a universal solvent, the density of pure water is 1 gram. Density of pure water is 1 gram per what? cm3. So if we use density as 1, we are going to get mass to be 1000 grams. So doing that now, we say that density equals mass over volume, right? So density is what now? 1 equals mass, we don't know, over, what's the volume? 1000. Cross multiply. Mass will be equals to what now? 1000 grams. So this is 1000 grams of water. This is the mass of water. Having gotten the mass of water, do I know the molar mass of water? Yes. Molar mass of water. Water is H2O. If you solve everything here, you are going to get 2 times 1 plus 16, which will give us 18 grams per what? Per mole. So it then means that the molar mass of water is what? 18 grams per mole. Alright? Can I now get the number of mole of water? Yes. How do I do that? I will now say number of mole of water equals, what's mass of water now? 1000 divide, what's the molar mass of water? 18. So we check 80, 1000 by 80. 1000 by 18, let's see. So 1000 divided by 18, we have it as 55.5. So number of mole of water equals 55.5. Please, this is very, very important when we are solving this kind of calculation. All right. So you can do well to pause the video because I want to use this space to finish up the solution. All right. So using up this space, I can write the solution down. So doing that now, look at our formula now. We said to get the mole fraction of glucose, we take the mole of glucose over the sum of the two of them. So mole fraction of glucose Xg equals, what's mole of glucose in the, I have gotten, mole of glucose, that's 21.6 divided by 180, which is 0.120. Divide, what's the total? Mole of glucose 0.120 plus, what's moles of water now? 55.5. 55.5. So we'll just grab our calculator and punch. Mole fraction of glucose will now be equals to, all right, mole fraction of glucose will now be equals to 0.120 plus 55.5. That gives me 55.62. So this becomes 0.120 divide 55.62. You can as well grab your own calculator to check the final answer. So mole fraction of glucose will now be, all right, divide, we have it as 0.00215. So this is our mole fraction. Let's look at the options. Okay, our options are in standard form, of course. So if you put this one in standard form, now that's like shifting this point to this place. 1, 2, 3. That's 3 times. It becomes 2.151 times 10 raised to the power minus 3. Why minus 3? Because this number is less than 1. So let's check. 2.15. Option A. 2.15 times 10 raised to the power minus 5. No. 2.15 times 10 raised to the power minus 6. No. 21.5. No, that one is not. 2.15 times 10 raised to the power 3. That is not our answer. So our answer is supposed to be 2.15 times 10 raised to the power what? Minus 3. That's option E, which is the same thing as this value here. That is much we can take for this video. Remember, I just solved a problem now. This example 3, for those students that have been disturbing me when mole fraction is given and we're asked to find molarity, what do we do? Do well to understand what I have solved here. This is the method, the way we go about it when we are given mole fraction and we are asked to find molarity, or when we are given molarity and we are asked to find mole fraction. So this is the method we use. All right. Remember to subscribe and remember to share. Share this video in all class group chat so that your friends can benefit just as you are benefiting. See you in our next video.